All right. How's everyone doing? Just getting started with this uh, live code session pretty soon. So it's been a while. So sorry about that. It's been a while since I was able to do one of these, but I was just kind of busy with a bunch of trainings and I had a lot of other work to do, especially with releasing something very interesting that's coming to you in January. But anyway, so this was the reason why I was not able to really work on anything related to live code. And to be honest, I kind of ran out of some topics to do live code as well. But as we've been doing a little bit more work in the cloud security space, I've been learning a little more Go and TypeScript and stuff like that. So thought we'll talk about some of these subjects in today's live code as well. All right, so let's get started with today's live code, and I'm gonna get started with why I chose this topic and why actually this came about and what are the objectives of this particular topic. So I want to build a password manager, and I have some constraints that I've set for myself while building this password manager. The first thing being, I don't want to. I want to leverage pretty good or reasonably good quality of encryption, easy to use encryption, but very good quality of encryption as much as I can. So that was one of the objectives of this live code session that I had. The other thing that I wanted to do was while building this password manager, I wanted to ensure that I leverage keys or cryptographic keys that are already in my computer. So as a developer, I use SSH a lot. I'm sure some of you watching this are also likely to be using SSH a lot. So I wanted to leverage SSH to do some wrapping or some other kind of cryptographical operation related to this particular project. So I set a constraint for myself that I have to use SSH to be able to actually do this in a more meaningful way, in a way that is actually secure. At the same time, I also wanted to build a password manager that is completely system contained, which means that the data does not leave that particular computer. There is a local data store, but the data does not really leave that computer. So a few constraints. One, I want to leverage SSH because SSH is on most of our machines, right? So especially if you're a developer, likely you're using SSH, you probably have some SSH keys. You want to leverage those SSH keys to be able to do this. The second thing I want to do is use strong cryptography and secure by default libraries as much as I can. And third, I want to keep this a local password manager. I'm not using any of the cloud features, and I'm not using any of those network capabilities to be able to do this. I'm not using a secret manager like HashiCorp Vault or something like that. I just want to keep this simple, straightforward within the same machine. At the same time, I want to be able to leverage that as a password manager. And the fourth, of course, the constraint that I didn't mention, although I like to use Python most of the time, I wanted to build this in Go. One, because I was learning Go, I wanted to understand the cryptographic APIs in Go, so I decided to use Go for this. So that's the reason I'm using Go for this particular project. But yeah, let's get started without further ado. So I'm just going to change my view here. Um, to just a little bit. I think this is too much of a. Oh, yeah, looks like this is the right layout that we want. So I'm going to start with a project from the beginning, and I'm going to explain the project as I go along. So let me just start off by opening up a new project directory. I'm going to create a new directory here called local paths. I'm going to call this project local paths. So I'm going to cd into local paths, and I am going to then open this up in Visual Studio Code, right? So I'm going to open this up in Visual Studio Code, and let's get started with building our password manager. I'm just going to open it up a little bit more for me to be able to, for all of you to be able to see this as well. Now, the first thing I'm going to do is I'm going to be using a CLI. So this is something that I want to be building as a CLI and not as some kind of an API or something like that. I just want to use this as a command line tool that I want to use on my terminal. So, and I want to keep this generally available for Linux and Mac machines. So I'm going to be building a CLI. So I'm going to be using a very interesting library for Go, for CLIs that can be written in Go called Cobra. So Cobra is something I'm going to just, I'm going to paste the link here pretty soon. So Cobra is a pretty cool library. I've been using it for a while now. And I've been using Cobra for a while. And this is a CLI tool that allows you to kind of make CLIs a lot easier. It's a lot more easy to generate your CLIs. It's a lot more easy to kind of write up your CLI. So it's pretty cool to use Cobra. It kind of gives you a lot of a lot of boilerplate code right out of the box. So yeah, so CLIs are pretty cool. And Cobra is a really good library that I've always liked to use for CLI. So I'm using Cobra for building out this CLI, right? So the first thing I'm going to do is open up my terminal here, uh, and let's get started with that. I'm going to open up my terminal and I'm going to have Cobra. I'm going to use Cobra's auto gen capability, right? So I'm going to first basically, Cobra has something, it generates the commands, it generates the CLI boilerplate structure for you. So I like that. I don't want to sit and reinvent the wheel all the time. So I want to be able to just use their capability to actually generate the CLI commands and stuff like that before, and I can actually focus on building my application nets in itself, right? So what I'm going to do is I'm going to init this. So Cobra, what I'm going to do instead of, so I'm going to, you initialize a project with a particular package name. So I'm going to say GitHub local pass, right? So it's going to initialize that, and you can see it already generates some boilerplate code. It generates a root command, generates a it generates a starting point, which is the main.go file, which executes the root command, and of course all the other commands based on that root command. Now for this, I need a few commands, right? So this is a password manager. So I need a few commands for this password manager to work. I need a set command. I need a probably a configure or initialize command, and I also need a get command. So I'm just going to implement 3 commands right now. A set command to set my password and encrypt it and store it in my machine as a password that I can retrieve later on. A get command to retrieve that password, and an initialize or a configure kind of a command that I can use to actually configure my the configuration parameters that I need for my tool to actually access whatever it needs to access, right? So I'm going to add that with the boilerplate code that you can do. So you can just do Cobra add set Cobra add. So it actually creates these commands for you with some boilerplate code. That's why I like the generator capability of Cobra. So I do Cobra add get, then I'm going to do Cobra add init. So I just want 3 commands. I want to be able to actually use 3 commands to start accessing Cobra and actually start using my CLI. So my CLI essentially is going to consist of 3 commands, which is set, get, and init, right? So the first thing I want to do is write up my init code, right? So I'm going to write up my init code, which is going to initialize my my application or initialize my CLI and my tool right on my machine. So I'm going to remove this stuff, and I'm going to start writing up my initialization code, and I'm just going to run through this pretty quick, explaining what I'm doing as I'm running through it. Okay, so it adds the init command to the root command. So if you actually call the init command, it will refer to this particular command, right? So the first thing I want to do is I want to create a directory or a base directory for this tool in my slash home. So I want to keep this in this directory, right? I want to keep this in slash home slash dot local pass, right? So I want to keep this in dot local pass as the base directory. So I want to store my database for this particular tool that I'm building in the slash home path in dot local path local pass path, and I can have my database and whatever else I need to store here, I can store in this. So I'm going to create that. So I need to create that directory and then of course start to access that particular directory and start to use that as my baseline, right? So what I'm going to do first is I'm going to initially get I'm going to first get the user's home directory, right? So that Go has the functions that allow you to do that. So if I import the OS user library, I'm going to be able to get access to the current user, and get access to the current user's home directory. Okay, so I'm going to say if is equal to not equal to nil, then we essentially log dot fatal. So I'm going to say that whatever is the error. But if there is a user directory, then we want to set that as the root directory, right? So I'm going to set that as the root directory. I'm going to create a variable saying, okay, this, you initialize a directory called local paths. This is your base directory where you're going to store the databases related to this particular tool, right? User.homedir. Homedir is the slash home path. So this is going to be the slash home path for that particular user, right? Then we're going to, now we also want to initialize this with an SSH key. Now remember, I wanted to leverage SSH keys. So that's why I need to have an SSH private key and a public key location that I'm going to be using. Now, can anyone tell me which is the default SSH private and public key that is available on most machines? Anyone who's watching this, anyone wants to add? So the default SSH private and public key locations are in home dot ssh dot and ID RSA. So the ID RSA is the private key and the ID. Typically, this is again not in all machines, but IDRSA.pub is the public key. So we're going to be using this as the basic. So we're going to actually we are going to allow the user to set up, but if the user does not want to set custom directories, then we are going to allow the user to use this default private key and public key, that is your SSH RSA private key and SSH RSA public key, right? So we're going to allow the user to do this. So I'm going to say def priv is equal to again from dot sprintf slash dot ssh ID RSA, right? So we want the private key user dot homedir again. So I'm just string substituting that. Def pub is equal to from dot sprintf and again same with dot ssh dot id rsa dot pub. So this is the public key and this is the private key. The reason we are doing all this is to make sure that we set these as defaults, right? That's the important thing. We want to set these as defaults when we're using our CLI, right? So what I'm going to do now is I'm going to create my flags for my command, okay? So I'm going to say init cmd dot flags. So I'm going to create a string flag. So this is in my CLI. Since I'm writing a CLI, I need string flags for my CLI. So I'm going to say you need to pass a string parameter called database. Where do you want your database to go? You also have a shortcode called D, which you can call. So you can do something like local pass slash D, or you can do dash dash DB, right? So you can actually use that, right? So I have a question from Didar who says, which OS I'm using? Mac OS. This works on, I think it will work on Linux as well, this code. Not sure about Windows, but it should work on Linux and Mac. So I'm going to use this, and then I'm going to set the root directory for this, because remember, I want my database to be stored in the root directory. So this is the root directory, which is local paths, right? So I'm going to store it in the root directory. I'm going to create a directory called local paths. It's going to store it in that directory. Okay, so this is the absolute. Just going to type out some basic help text. Not going to do much with this, and I'm just going to quickly copy the private and the public keywords that I need for this, and I'm going to keep this R and I'm going to keep this P. These are just references that I can use. I'm going to use def priv and def pub. Sorry, def pub. That was the wrong one. Def pub. So I've created some flags, and I've already created the private and public. In fact, let me keep this U to avoid any confusion. So private and public. So that's basically what I'm doing. So I already have a CLI. I already have a minimal CLI with an init command. Now what I'm going to do is actually, I'm going to actually write out the capabilities of that CLI. So let's see what I'm going to do. So I'm going to first create my conf directory, which is going to be cmd.flags. So I'm going to get the get string database. So I'm going to get the database. So this is when the user actually starts using my CLI. What do I do with it? That goes into the func run aspect of the func code. Yeah. So it is essentially a struct that uses a run which takes in a function that allows you to execute the commands from that init command, right? So I'm going to use that the database here, and I'm going to, this also needs an error resolution, so I'm going to use that, and I'm just going to quickly take in both the other commands. So I'm going to say priv and pub. Priv and pub. Okay, so I'm going to say priv, and of course we need the pub variant. Right, so we have the commands that we can actually consume. Now I'm just going to add some error conditions. I do have some existing error conditions to check whether this private key, public key does exist or not. So I'm just going to copy that, paste it in here. So this just checks if that private key does not exist or the public key does not exist, and it throws an error and it exits the program. So we want to actually have a valid private public key, right? So that's basically what we want to do. We want to check if that file actually exists or not, right? So that's what we want to do. Now, the next thing we want to do is create this directory called .localpath, right? Now, if we create this directory called .localpath, it's going to store the database in there. So it needs to create that directory called .localpath. So that's what we're going to do next. So we are checking if that file or that path exists with os.stat. We're going to check whether the conf.dir exists, and if it does not, is not exist. If there is an error, then we are going to. If there is no error, of course, we're going to throw. If there's an error, we're going to throw the error. But if there's no error, then we're going to create a directory, right? So if there is no directory in there, we're going to create a directory, right? So basically, that is going to be your conf os mode firm, right? So basically, that's what I'm doing. I've created a directory. This is going to be a dir error, right? So I'll just use a standard error here. I can just keep returning a single error reference. So if error not equal to nil, then we can log.fatal enable to create directory. All right. So basically, I'm just creating that local path directory. Otherwise, we can print out from.println created directory. So this is just a success command. Now what we're going to do is we're actually going to be using a database, right? So we want to use a simple embedded database for our application. So what is a good database? I've been looking at different simple embedded databases where I can use a key value store in my local machine, and I came across Pebble. Now Pebble is recently built by the team at Cockroach Labs, and this is a pretty interesting database. I found it looked pretty easy to use. I found it, and I've been using it since. It's a pretty interesting database, very easy to use. Just simple key value store, doesn't do anything fancy. Just want to use key values, nothing more. Since I'm just using it as a password store, I'm just looking for a specific key which is going to give me a specific value. I don't really care about, okay, do I need to search for this? Do I need to query based on this? I'm not using any of that. I'm just using a basic key value pattern here. So I'm going to create. The database first. So I'm going to say dblog is equal to prompt.printf, and I'm going to create a database, right? So this is going to be my string reference. I'm going to call this database noyb.db, none of your business.database. Since we are building a password manager, we don't want anybody peering into this password manager. And of course, we're going to be using decent encryption to prevent that from happening. So we're going to call it none of your business database, and we're going to be using that, right? So we're going to create the database, and we're going to actually use Pebble itself. I've already installed Pebble, so I'm going to say pebble.open dblock in this location with no additional. We're not going to pass in any specific options. Options. So we're just passing in, and if the database fails to open, we are going to, of course, print it out and say, hey, sorry, we couldn't create that database, or we couldn't access that database, unable to create DB. Now let's actually store the private key location and the public key location in the database. So in this case, what we're going to do is just store the two locations. Remember, we're not storing the actual private and public key. We're just storing the file locations in the database. And we're just going to create a key called in the database called priv key, which is going to be a byte slice of type priv. And we're going to store it in that. So if db.set priv key, we're going to convert a byte, create a byte slice of our priv string, which is the location. Remember, we got the location of the private key from here. So we're going to store that as the value. And we are also going to synchronize it with our database, which is going to write it to the database. And if it does not, just give me a sec. I'm just doing that, making sure that there are no errors. If there are errors, then obviously we're going to say that, unable to write the path to DB. Now I'm going to take the same thing, since I'm going to be doing the same thing with the public key. I'm just going to create a slightly different reference. I'm using a new keyboard, so please forgive my butterfingers on the keyboard, and it's always difficult to talk and type. So this is going to be pub, and I'm going to say. So now we actually have a initialization function, right? So we actually have an initialization function. So we're going to close the database. We're going to print it out. So we actually have an initialized CLI all ready to go. So local paths successfully initialized, right? So all this is done. We've successfully initialized our application, and we're going to close our database. So we're going to say database.close. If there is an error, then we're going to log that fatal database unable to close. Right. So basically, now we have a init capability to our code. So if we actually do this, if we run this code in our machine, so I'm going to say go run. Now remember, we've implemented an init function, so it takes in two arguments. Both those arguments are three arguments. Sorry, all three are optional arguments because they already have some default values. So it's going to create a directory in my home directory called .localpath. It's going to take a default ID RSA private key, ID RSA public key from my .ssh directory, and that's what it's going to initialize all those values with. So if I do go run main.go init, which is I'm just going to run it in a local invocation. I'm not created a distribution for this. If I just do init, it should hopefully create my, so it created the directory and it initialized my local path. So if I actually go ahead and do .home/, it would have created my local paths directory, right? And it also creates my database called noyb.db. So we've got all this stuff running. We have the database running. We have the database set. We have the directory, the boilerplate directory, and we've got an initialization method. Now let's start putting in some passwords, and let's start actually encrypting and handling that. So I'm going to start with our set command next. So I'm going to close the terminal now. And I'm going to start with our set command next. So which means I'm going to start working on our set command. We have an init method, but we're going to have to actually set stuff, right, in that method. So we're going to actually have to set a password, which is going to get encrypted and stored in that database. That's what we want to achieve, right? So we want to store the data within that set password capability, right? So this is going to have a few flags required. We need a key and we need a password. So whenever you're setting something, you need to set it with a particular identifier saying, hey, this is the key. I'm going to query this key and you give me the decrypted password, right? That's basically what we're doing. So in this case, what we're going to do is we're going to say set command dot flags dot string key, which is the key. So we are going to set a key, which is referred to also with the k value. It does not have any default value. And we're going to say key for which value is set. This is the help text. Not very helpful, but nevertheless, we're just writing something. So this is going to be, let's call it a password instead of using a P or a value thing. So we're going to call it a password, and we're going to use a /P, and we're going to set up the value for the key. Right. So basically, we have two things, and we need so we're going to mark a particular flag required. We're going to mark both the key and the password value. Right. So basically, command mark flag. So I'm going to make the user forcefully enter both these values. Only if the user forcefully enters both these values will my CLI actually. So it's like input validation. That's what I like about Cobra. It gives you all these cool capabilities that allow you to validate stuff right then and there. It allows you to set constraints and make you work on those constraints. So I like that about Cobra. It's pretty cool. So what I'm going to do now is I'm going to start writing the functionality for that. So let's first get the values of both password and key, right? Now, ideally, you should not be having password being entered on the command line. You can because especially when you're having might have people looking over. I do usually implement a separate password prompt that is truncated, but since we are doing this as a demo, I don't have time to implement that. I'm just going to go ahead and make that user enter the password right on the command line. So, but usually what you should do is have a password prompt where you mask the user's password, like you do, in SSH and all that. You have this password prompt that masks the user's password. I like that, but since we're not doing that, I'm not going to build that functionality. So what I'm going to do now is, remember, we need to encrypt the password, and we are going to use the key as the identifier for that encrypted data set. Now, there are two things we're doing here. Now, remember, there are two things we're doing. So we are doing envelope encryption. So what we're doing now is we are encrypting, let me just give it a line, encrypting password with a symmetric key. And we are encrypting the symmetric key with our SSH public key. So it's dual encryption, right? So first thing, we're encrypting the password with a symmetric key. So this is going to be a symmetric key, a nonce, and of course, it's going to have both these values that's going to be with it. Then we are going to encrypt the symmetric key itself with our SSH public key. So since we're using SSH, like I said in the initial thing, I said one of the constraints we have is we're using SSH for this because SSH is on most people's machines, and we're going to be using SSH keys to actually do our encryption. So we are encrypting the data with our symmetric key for speed and of course randomization, and then we're also going to encrypt the symmetric key with our SSH public key. So the passwords for the key for each and every password is going to be unique, but the wrapping key is going to be our SSH public key, where we're going to unwrap it with our SSH private key. So please keep that in mind. So the symmetric key is going to be wrapped with our SSH public key, and then we're going to use the SSH private key to actually unwrap our key, right? Basically, that's what we're doing here. So let's actually start doing that. Let's implement a function to encrypt stuff. So I'm going to implement a function called encrypt data, right? I'm going to encrypt the data. So I'm going to say function encrypt data. Here I'm going to pass in a message, which is a byte array. And then I'm going to essentially output a byte. And I'm also going to output a key size. So 24 byte key, byte array of 24. And I'm also going to, so this is going to be our key. So let me actually declare that as constants. Hold on. I'm just going to create two constants here, which are important, just easier instead of referring to them as 24 and 32 and all that stuff. So I'm going to say key size. It's going to output that because remember, I need to also store the key. And I'm going to also be using a nonce. Nonce is a salt, an initialization vector that we're using to actually encrypt stuff, right? So in this case, I'm using a 24 byte nonce. So 32-byte key, 24-byte nonce. That's what we're using here. So you can see that we have our function called encrypt data. It gives me some warning, but that's fine. That doesn't matter. It's just a documentation warning. Now let's actually implement our encrypt data, and let's actually start encrypting stuff with it. So before we start actually encrypting stuff, we need to generate a key and generate a nonce. So let's actually do that. Okay, so let's func generate key, and of course it's going to output a byte array or and an error, right? So it's going to do one of those things. So we're going to generate a key and then we're going to generate a nonce. But we're going to do both these things. In fact, we can actually use the same function. We can just say generate rand, except that we need to pass in a particular. So I guess we could do it this way. Actually, let's do it this way. Yeah, let's do string of type. Okay, let's do mode, which is a string mode. Okay, so we can do an if condition and then check. If we want to generate a key, then we use a 32-byte array, or if we want to generate a nonce, then we use a 24-byte. So that's what we're going to do. So we're going to generate random value that is, so if mode equal to key, then we're going to generate a key value. So that's going to be key colon new of key size, and we're going to key size of bytes. So we're going to generate a byte slice of 32 bytes, which is the key, and we're going to io.read full rand.reader. We're going to copy the key value to this random value, generate a random set of bytes, right? So then if the error, of course, is in there, then we're going to do log.fatal and say, sorry, unable to read random. In fact, not log.fatal. I'm going to say return nil, and we're going to say error. We're going to return the error if it's not happening. Else, we're going to return the key and nil. So if the mode is not key, then we just obviously want to create a nonce. So we're just going to return a nonce. So in this case, I could have probably optimized this a bit more, but my apologies. I'm just going to do it this way. I'm just gonna. I could have done it a little bit better. Could have been more optimized for sure, but I'm a piss poor Go programmer, so don't mind me. I'm just going to be doing it like that. So this is going to be nonce, and I'm going to say nonce. Same thing, pretty much the same thing. I'm just generating random key and a random nonce, right? So basically, that's what we're going to be doing. Oh, okay. I think that was the issue. Or you can't generate multiple types. Okay, we can't generate varying length of bytes. Actually, we could generate a nil. So we could do a key size byte or a nonce size byte. Again, I'm quite sure this is not great code, but I'm just doing this because we want to move along. We don't have all day for this live code session, so just want to make sure that I'm quite sure that, so this is going to be key size nil and nil, right? So nil, error. So just returning two nil values. Is that okay? Oh, you can't. Oh, man. Sorry about that. I think I'm just going to have to separate this into two functions. Let me just separate this into two functions. That's the point anyway. So I already have some boilerplate here. So I'm going to just separate this out into two functions. Generate key and generate nonce. So I'm going to just do it that way. I'm going to generate the key. I don't know why I call this session key, but so I'm using it like a single use key. So that's why I think I called it session key. So generates a key and generates a nonce. So both these functions are implemented. Let's actually start encrypting our data, right? So first we want to generate our nonce. I'm going to say nonce, error generate nonce, and we are going to get back a nonce value if error equals nil. Then we return nil. We also need to return an error here. So nil, nil, nil. Oh, we have a nonce size. We have a byte array, we have a key array, then we have a nonce array. So we are returning all these things, and then of course we are uh, generating an errors dot new unable to generate nonce. I'm going to do that pretty much the same thing with the key. It's almost the same thing. It's going to be key and err generate session key, and pretty much the same thing, except that instead of the nonce part, we're going to generate the, we're going to throw an error for the key. Now we're actually going to encrypt stuff, right? Now let's generate our ciphertext. So I'm going to be using LibSodium in this. Now, if those of you who have not used LibSodium, you can check out LibSodium. So LibSodium is a really cool secure default encryption algorithm or misuse resistant encryption algorithm, encryption library, not algorithm, sorry. LibSodium gives you strong modes of encryption right off the bat. It does not even support weak modes of encryption or weak modes, weak cipher suites and stuff like that, or weak ciphers in itself. It only supports strong ciphers. It's a very opinionated library, but it's very easy to use and it's pretty powerful stuff. So which is why I'm using LibSodium. So let's generate our ciphertext. So the first thing we want to do is so when we are generating the ciphertext here, so the first thing we're doing is we're encrypting the password with the symmetric key, right? So we're encrypting the password with the symmetric key. That's what we're doing. So in the ciphertext, you also have a prepended nonce. So the nonce is prepended to the ciphertext and then generates the entire ciphertext. So when you're decrypting, you first need to separate the nonce from the ciphertext and then decrypt the entire ciphertext. That's what you need to do. Okay. So now if we do a ciphertext, we're going to create a byte array of cipher of type. I mean, we're going to create a byte slice, not byte array, of length nonce. So first thing we're going to do is prepend that. So we're going to say of length nonce, and then finally we're going to copy the ciphertext value to the nonce slice, just making sure that we have a nonce slice. And then finally, we are going to generate our ciphertext. No, it's not nonce size. Typo in 57. Oh, thanks. Thank you. I appreciate that. I wouldn't have got that. So we're generating nonce, and of course, we're going to generate our final ciphertext. So we're going to say ciphertext is equal to secret box. So I like this concept in LibSodium where you have this secret box. You say secret box dot seal, and the developer, it looks pretty simple. It's just like sealing something in a secret box, which is really nice. I like the use of verbiage while creating the functions there. So I'm going to generate the ciphertext, which is actually our plain text value. So that's what we're using here, the plain text value in itself and the message value in itself. So we are generating that prepended nonce value, then we have the message itself, and then we have the nonce, the actual nonce value, and the key. So when we use all these things, it generates our ciphertext. And we're going to return this ciphertext, right? So we're going to say return ciphertext key nonce nil. So there are no errors. So if this has gone through without any problem at this stage, you just have to, it's going to generate your ciphertext with no errors, right? So if it comes to this point, it's going to generate your ciphertext. You need the key and the nonce because remember, you need to actually, you actually don't need the nonce, but I'm going to return the nonce anyway. The reason why you don't need the nonce is it's prepended to the ciphertext. So when it generates the ciphertext in the secret box, the first 24 bytes of that ciphertext happen to be the nonce value, right? So that's something you should keep in mind. So that's why I don't need to necessarily return the nonce, but in this case, I'm just going to do that. Okay, so now we have this. So let's finish our first process. We're going to generate our encrypted payload. So I'm going to say ciphertext. Let's call this C text. And key nonce error. Right. So it's saying encrypt data, then our message, right? Whatever message we want to encrypt, our PWD, our password is something we want to encrypt. I do that. Now, if there is any errors, we're going to throw that error. I'm going to say log.fatal error. Right. So this is where we're going to throw that error. But if there are no errors, then we need to create that into a binary. So what we're going to do is we are going to encode that into a binary object in Go called gob. Now, gob is a pretty it's actually used for network encoding and decoding and things like that. It's just I think it's used as a serialization approach in Go, where you have encoded data sets that are sent to a machine and that can be decoded with gob. So I'm just going to paste that link for all of you here. You can check this out. This is an encoding format. It just allows you to encode binary values and decode binary values in Go. And this is what I'm going to be using to store this in my database. So I'm going to be storing this in my database. So I'm going to be encoding that value in my database as well. So what I'm going to do now is I'm going to use Go to encrypt and decrypt. So I'm going to say var enc payload. So this is the data that I'm actually going to encrypt. So I'm going to use a byte buffer for this. I always type in bugger for buffer. So sorry about that. I don't mean to curse. Let's see. So I'm going to create my payload itself, which is going to be gob.new encoder. It's going to create a new encoding with the reference to int payload. So dereference that. Now error is equal to go payload dot encode. So it's going to encode the payload in a particular struct. So I need to create that struct now. So this is an object where I'm going to be type encrypt payload struct. And this is going to contain the plain text, the ciphertext, and the encryption key. So it's going to contain the encryption key, which is a pointer to 32. Let me use the actual key size, right? And this is going to be the nonce, which is going to be the nonce size of byte. And then the actual ciphertext itself, which is going to be a simple byte array, byte slice. Right, so this is the encrypt payload. So what it's going to do is it's going to encode that all the return values in that particular in a struct, and it's going to package that and create an encoded binary value of that I can store in my database. Right. So what I'm going to do is I'm going to encode this. Give me a second while I try and encode this. So far I've encrypted my data, but I need to encode this. Encrypt payload. I need to create my data set here, encryption key, my nonce, and my cipher, I guess. Encryption key, nonce, and cipher. Yes, that's correct. C text. So that's what, and this is going to encode that into that Go encoding binary, right? So it's going to create an encoded binary. If not equal to nil, of course, I need to handle the error. Log.fatal, don't need this here. Log.fatal error, right? So that's what I'm. Now the next thing I'm going to do is I'm going to store this in my data. I need to actually store this in my database, right? So I need to store this in my database. So I actually need to open my database. But before I have to store it in my database, remember, I need to actually, I've only done this. I've implemented this, which is encrypting the password with my symmetric key. I still need to take whatever value is output from here, this encoded binary value, and then encrypt it with my public key. So I still need to do that. For that, I need my public key. And the way I get access to my public key is I go to my database, get the path of the public key from my key value store, go to that path, pull out the public key, parse that public key, then use that public key to encrypt this encoded binary value that I have, and then generate my final ciphertext. That's what I want to do. So I'm just going to copy a little bit of that. So this is going to be stuff that I don't want to explain because this is kind of. So what this code is doing, just for all of you to understand, is that it is just going to that particular directory and it is fetching the value of that public key, right? So just fetching the value of that public key. Again, I could have made this into a standard function in a shared Go module somewhere, but again, just for the purposes of this, just to give you an idea of what's happening here, I'm just doing that. Right, so I've created, so this is going to fetch the public key from my database, and I'm going to use that public key to actually encrypt my symmetrically encrypted data set. So the data set is already symmetrically encrypted. I'm going to use my SSH public key to use as a wrapper key, right? So let's create another function now to actually encrypt with this. So it's called func encrypt with pub key, right? So I'm going to call this encrypt with public. Let's call this public key. That's fine. So we are going to pass in a byte slice, and we are going to pass in the actually we're going to pass in the key value. Obviously, we need to pass in a key. So let me just check how we want to implement this. Yeah, we need the location of the public key, right? So this is the public key location. So pub key location, which is a string, and then we also need the symmetrically encrypted. So this is going to be C text, right? So this is going to be that, and this is going to return a byte slice and an error if there is an error. Right? So I'm encrypting with public key. It's going to take in these two arguments, which is the public key location, which is the string, and the ciphertext, which is your already encrypted password. Okay. So now what I'm going to do is I'm going to read my public key, and first I need to read and parse the public key. So the first thing I need to do is read and parse the SSH RSA public key. Then I'm going to have to, so the first thing this needs to do is that. The second thing I need to do is parse that public key into an instance of RSA public key. So just because you have an SSH public key doesn't mean you can just directly use that to encrypt and decrypt. Now, there are different types of formats that you have for public key encryption. So you need to, for Go to actually understand it as a public key, you need to cast that as an RSA public key, and then use that cast value to actually encrypt your payload. Then finally, encrypt payload with, which is your encoded binary. And then finally, base64 encode all of this to store it in the database. So this is basically what you want to do, right? So now I am going to first create my public key, read my public key. So ioutil dot read file pub key lock, right? So it's going to read that public key file. If error, again, as always, equals nil, then you return a nil and errors dot new, unable to read pub key, right? So I'm not able to read it if there is an error, right? We want to handle errors then and there. We don't want to read it. So the next thing we're going to do is parse the public key, right? So we need to parse it for it to work. So I'm going to say parsed, and I'm going to pass in some nil values here, which is essentially returned from the function that I'm going to use. It's also going to return an error. I'm going to use the SSH library, and it has a function in there called parse authorized key. So this parses a public key and returns a parsed value. and multiple other values as well. You can see it returns a comment, the options, the byte, the rest, and the error and stuff like that. It gives you all of the different parameters of that particular key. We don't need these parameters, which is why we are essentially casting up a null at this point in time. But so if you do need them, of course, you can same thing, unable to read. I'm just going to add the same thing. Unable, now, instead of read, we're going to say parse because that time we're not able to read it. Now we're not able to parse it. Now we remember we have to cast this to an RSA public key and then use that to actually encrypt our payload. So we're going to cast that. So crypto key. We're going to parsed dot. So we're going to cast that to an SSH type crypto public key. So this is a type that allows us to then use that as an RSA public key to actually encrypt. So implemented as a raw crypto public key. So which is a useful thing to do. It implements it at this interface. Then finally, what we're going to do is pub crypto. We're going to create this as a. We're going to take this parsed crypto key, and we are going to initialize that. So we're going to return it as a public key that which we're going to cast into an RSA public key instance. Okay. So then the next thing we're going to do is we're going to say RSA pub. Sorry about that again. So pub crypto dot RSA dot public key. So this is a now it's of type RSA public key. So that's what we can use to actually encrypt our binary, right? So let's encrypt our binary, encrypted bytes and error. And we're going to use RSA's encrypt OAEP. Now, OAEP is the optimal asymmetric encryption padding scheme that we're going to use. This is the scheme that is currently the most secure. Ideally, you should not be using RSA, but if you are using RSA, the padding that you should be using for that, aside from the fact that you should be using strong parameters for picking out your RSA parameters, should be the OAEP or the optimal asymmetric encryption padding scheme. So we're going to use RSA encrypt OAP, and we're going to use a SHA-256.new for the hashing process integrity verification. We're going to add a random value to the process, and then we're going to use the public key, of course, and then of course our symmetric, the ciphertext itself, right? The ciphertext ctext dot bytes. So we're going to generate the bytes for the and then finally we're going to return a nil value. Right, we're passing a nil value into the encrypt OAP parameter. So this is what we need. Not sure what happened here. Oh, it's a bytes buffer. Sorry, my mistake. This is a bytes buffer. So this is bytes, and then if error equals nil, then of course return nil start new unable to encrypt with RSA. So we have some error codes as well. And finally, we're going to return our encrypted bytes and nil because we don't have any errors. So what we did here is we didn't do this yet. So we've done 1, 2, 3. We've read and parsed the SSH RSA public key. So we've read the SSH key, parsed it, and then cast that to an RSA public key. And then we have encrypted the actual encoded binary value that we generated from the Go in the previous step and encrypted that with the public key. So that was already, remember, that was already encrypted. The password was already encrypted with the symmetric key. Now we're using an asymmetric key to wrap that entire binary data structure, right? So now we have this and we are almost ready to implement our actual get functionality. We're nearly there. And that's where we're going to be done pretty soon. Just making sure that we have everything in place here. All right. So let's then actually encrypt our value with the encrypt public key, encrypt with public key. So we're going to pass our string of value, which is our key value, which is our public key path. And then finally, we are going to send out our encrypted payload. So whatever payload that we used to create our payload, we're going to generate our encrypted value. And then finally, so now we have actually finished our encryption and we even wrapped it around our um, our SSH public key. So both of that is done. So it's pretty cool. So let's finish that up. Log.fatal. And then lastly, we are going to write this to base 64, right? So we're going to say we're going to write this to our database. So we're going to say db.set for the byte slice of key. We're going to create a byte slice of base 64 dot std encoding dot encode to string, and then we're going to pass our encrypted value, right? And then finally, we are going to sync to our database. And then saying, so this means that we have written that data to our database, right? So we have actually written that data to our database. Just adding some. So then finally, we're going to just write a success message where we're going to say, hey, you know what? We've been able to add our password for this particular key to my database. Now let's actually run this and see if it works. Hopefully, there should be no errors that comes up. Looks like it's fine for the most part, but let's see if it works or not. Let's go back to the terminal now. Go run main.go. Set, remember we've implemented the set command. I'm going to say set key. I'm going to call this my db pass, and I'm going to set the password hello123. So this should be encrypted, unable to fetch private key. Okay, looks like that's strange. Unable to fetch public key. All right, I'm not sure what happened here. Let me just rmrf. Okay, go run main.go init. All right, should have done it. For some reason, I am not able to fetch my public key value. db.get by pub. Let me just check if I made some mistake with the initialization bits of this code. Not that I know of. Defpop, defpref. Looks like there's something wrong with the way I've set my code, set my public key. Anyway, I'm not going to be able to debug this, but let me just walk you through the get code and show you the actual final result, because we're almost. So this is an actual program that I just wrote, and I'm doing the live code of that. So I'm just going to explain. So what this is doing is it is encrypting, like the same way we're encrypting it, we're also decrypting it the same way, right? So let's actually run this and show you what I'm talking about. Hopefully this works. So I'm going to RM. So I've called this tpass, and this is just the same thing. Go run main.go init. I'm going to initialize my password program, and then finally I'm going to set something. Go run main. So I'm going to set this. So in this case, actually I've done a much better job of implementation because I actually add a password prompt here. So let's just set a value. So I'm going to set a password here, and you can see that I can say. So it stores the value in the database. So it does the same thing. First encrypts with a symmetric key, and then wraps that symmetric key encryption with our asymmetric key, right? So it wraps it with our asymmetric key, and the asymmetric key happens to be our SSH public key. Now let's explain the set code, and I'm going to explain the set code and then show you how it works and actually decrypt something, show you. Right. So the set code starts from very simple. You for this. Sorry, we just looked at the set code. Let's look at the get code. My mistake. So the get code works pretty simply. You just have to pass in a key. You don't have to do anything. And what it's going to do is first, it's going to unwrap the encoded binary value or the first it's going to base64 decode the value. Then it's going to unwrap the encoded binary with the SSH private key. Remember, the encryption happened with the public key. The decryption is going to happen with the private key. So it's going to unwrap the value with the SSH private key, which is in this case an RSA private key, and then it's going to pull out the ciphertext, the message, the nonce, the pass, and the of course the key from the encoded binary, and then it's going to decrypt the password and give me a plain text password on screen. That's what's going to happen with this entirely, right? So I'm just going to show you how this works. So let's walk through the code. I'm just going to kind of close up some of this. So the first thing is we're going to get the key. We're going to open up our database. We're going to check if the key exists. So we're going to fetch the private key first, and then check if the key that the user is requested for actually exists. The next thing we're going to do is decrypt with the private key. So we're going to decrypt with the private key. So this gives us a byte slice. So what it's going to do is it's going to read the SSH raw private key. Then it is going to decode the base64 encoded value from the database, and then it's going to try and do an RSA decrypt. Just like we did an RSA encrypt OAEP, it's going to do a decrypt OAEP, and then finally it's going to return a decrypted encoded payload. It's still encrypted, so you still are not getting the raw password. You're just getting that encoded binary or decoded binary. So it's still an raw encoded binary at this stage. And then the next thing you're going to do is, so once you decrypt with the private key, you're going to decode the binary, and then we are going to decrypt to actually get our password. So if you see what we're doing here, we're going to decode it, and then we're going to take the ciphertext, the nonce, and we're going to open the secret box and get our plain text. Open the secret box and get our plain text, and then that's going to be our plain text that we have printed out here. It's going to be printed as a string. So let's actually do that. So let's run this. So go run main.go get. So I'm going to get this key value, which I've stored as hello world /main pass. So if I get this value, you'll see it should print out my password. So let's actually go run main.go. Let's store something else. Set -k hello world db pass. So I'm going to use the key called db pass, and I'm also going to set a password called hello universe. Yeah, so it's going to store this in the key value, in the key of hello world db pass. Now, if I get hello world db pass, go run main.go, get k hello world db pass, I should get my decrypted password value after. So it's going to first decrypt with the wrapper key, and then it's going to decode the binary, and then it's going to decrypt with the symmetric key and the nonce and all that stuff, and then finally generate our plain text. So this is a pretty strong example. As you can see, it's pretty strong because we're using first of all, we're using good quality ciphers for this. We're not storing it in Linux keyrings or something like that. We're actually using good quality encryption that we can control. At the same time, we are not generating any keys. In fact, if you see, we're not using the user's password as the key. We're not using any kind of poor passwords as the key. We're actually generating the keys in each and every instance, and we're also wrapping it with another set of keys, which is making it much, much more secure. So not only is it's misuse resistant, it's also the fact that it's beneficial because we don't have to think about it. We're using standard asymmetric encryption to wrap the keys, and we're using really powerful symmetric encryption to encrypt the actual passwords, right? So that's one of the benefits of using a structure like this. Now, this I have actually created. I have to still write up the documentation for this, but it's in my GitHub, and it's called DPass. I just created this. I'm going to paste this here so that everyone can check this out whenever you have the time. And yeah, so this is basically what I did. I am still going to write up some documentation for this. I wanted to do a live demo. I did do a little bit of it live, but there was some bug that I need to debug, and I can't debug it on a stream. So we want to make sure that I give you an actual example of this. So I had to figure this out and then rewrite it for you in this particular live stream. So I will write up the documents and the README for that. Any questions before we close? It looks like I have a question. Any good resources to learn DevSecOps? This would be a very expansive question. You probably want to write to me on Twitter or LinkedIn, probably help you out with a few things. Best to start doing your own research in figuring out things like tools and how they can be automated, and that's where you can get started. But in any case, probably write to me, and that's a pretty large and expansive question. Any question on the cryptography that I used here, on anything related to the cryptography that I used here? Just want to check if we do have any questions on the stream. I just want to make sure that I'm not missing any questions on the stream. All right, looks like we don't have any questions on the stream. But if you do have questions, you can follow me at Abhay Bhargav on Twitter. You can follow us at V45 on Twitter, and you can also follow us on LinkedIn. You can follow us on all the major social networks. We are around. If you want to ask me a few questions, you can always do that, and I can get back to you as soon as I can. All right. Thank you very much. Thanks for watching, and I hope this has been useful. I have shared my code as well, so please do check it out if you want to learn more. If you want to ask me any questions, let me know at any given point in time. Thanks very much, and have a great rest of your day wherever you are. Ciao. Bye-bye.